question about drawing a structure. How do we go about doing that? How do I figure out how to draw, what to include, what not to include? The first thing that you want to do is you want to read the question and see if it says show the formation, means you got to draw all of the electrons and draw curvy arrows to show where they go. If it just says draw the structure, then you just draw the final structure. Now you can still draw the curly arrows, which I'm going to do here, but I don't need to draw the curly arrows because I haven't asked you for it. And typically on tests and exams we don't ask for that because we just want to see can you do the final product. But I'm going to show you how to come up with the final product. So the first thing you do whenever you're given something is to figure out, like, is it going to be ionic, is it going to be covalent, because both of those have different structures. So the first thing we look for is what are the things that I'm putting together to make a structure. In this case we have sodium, which is a metal, and sulfur, which is a non-metal. And I know that when you have a metal reacting with a non-metal, we end up getting an ionic bond. So an ionic bond. Ionic bond means that there is a transfer of electrons from the metal to the non-metal. So this is going to give its electrons to that. And then when I have my charged ions, they're going to be held together by electrostatics. So I need to have that all balanced. So what am I going to do? Well, let's go down here and change color. First thing I need to do is look on my periodic table and find out how many electrons these guys have. So I look at sodium and I find it's in group 1, and group 1 means that it has one valence electron. Sulfur is in group 16, and so it has 1, 2, 3, 4, 5, 6 valence electrons. I've got to figure out the arrangement. What's the best thing to do? Well, obviously sodium doesn't want to gain electrons. It wants to lose that one so that it has a full outer shell. So it gives 1 to this sodium. That means that that sodium now has lost all of its valence electrons and is happy. So I redraw it as an ion, empty shell. Your ions are either going to have an empty shell or a full shell. If you have any other electron arrangement besides empty or full, you haven't done your ions right, so you need to go back and look. So sodium is empty because all of its inner shells are full, it's happy. How many electrons did it lose? It lost 1 electron, means it has a 1 positive charge. It has 1 more proton in the nucleus than it has electrons outside. This sulfur, however, doesn't have 8 electrons. It has 1, 2, 3, 4, 5, 6, plus sodium's one that it just gave it, which I'm going to draw as an X, 6. So it needs another electron. Where can it get another electron? Well, the only option I have is sodium, but that sodium gave an electron. But when I write down sodium here in the problem, it doesn't mean I give you 1 sodium atom. I can't. It's impossible. The smallest amount I could give you is at least tens or hundreds of sodium atoms. And so if I happen to need another sodium atom, so that it can donate another electron, it's there. That means I have a second sodium ion because it's positive. And now this sulfur has 1, 2, 3, 4, 5, I'll use X, 6, 7, 8. It has 8 electrons around it, and so it's going to be quite happy, quite stable. The X is the same as a dot. I'm using that to show you that those are electrons that were gained from sodium. It gained 2 extra ones, so it has 2 extra negatives than protons in the nucleus. Now, just to keep things straight, I'm going to erase those X's, not because you couldn't leave them. You can leave X's there, it's fine. But typically we just draw dots in there, so I'm just going to use a different color of dot, so that way you can see that those came from the sodium. That would be the structure. This is all that I need to draw. If you understand how to do that and you want to go and skip this step over here, go ahead. This is all you would need. If it just says draw the structure, that's the structure. If it says show the formation, I need to show this. But if it doesn't say that, I don't need that one. The other option or the other type of bond that we're going to get is a covalent one. The covalent one is going to be given to you a little differently. Usually it'll give you the formula here. Sometimes it will say carbon reacts with 2 oxygens to form carbon dioxide, it could give it to you like that. But typically I just write out the formula. So if I gave you something like this, you'd have to come up with the arrangement. Now, I notice that I have 2 nonmetals. When I have 2 nonmetals, that's a covalent bond. Covalent means co-2. Valence electrons, they're sharing their valence. They're covalent. So carbon, that's 1, 2, 3, 4. Oxygen, now I have 2 oxygens. You always want to arrange them as symmetrically as possible. So I'm going to put 1 oxygen over here. 2, 3, 4. So just correct those. 5 and 6. How do I know this? Carbon is group 14, so it has 4 electrons. Oxygen is group 16, it has 6 electrons around it. Symmetrically would either be side to side or up and down. It doesn't matter what you want to choose. I'm going to do side to side. And that's what it would look like. Now, if I draw it this way, I've got my paired electrons close to unpaired electrons, which is fine, but we just want to simplify it. So what I'm actually going to recommend is if I flipped this oxygen, this one would go over here, and this single electron will go over there. So all I'm doing is kind of, if there was an axis here, I'm just turning it. I'm just turning it around. That's all I'm doing, so that electron is there. So now these are a little closer. Okay, once I've done that, I do the exact same thing I did before, but instead of giving electrons, I have to find ones that are going to share. Well, this looks like an, oops, I don't want to use blue. I want to use red. That looks like a good arrangement for sharing, and that looks like a good arrangement for sharing. This looks like a pretty good arrangement for sharing. And I only have 2 other unpaired electrons. I've got that one and that one. That doesn't look like a great arrangement, so I would have to redraw this structure because that's not really representing what's happening. Anything that I've paired up, any unpaired electrons that I've now paired so they can be covalent electrons. Any valence electrons that are unpaired, I try and pair them up. I'm just going to redraw this, and instead of drawing this circle around that pair, oh, I'm running on reserve power. Instead of drawing a circle on that pair, I draw a line. And a line represents 2 electrons that are shared between 2 atoms. So that's this one. This funny swirly one, I'm just going to redraw in here because it's a lot neater. Then there is 2 bonds between this carbon and that oxygen. And the electrons stay where they are. And that's how I would draw the structure.